Hi everyone, myself Dr. Sai Prudvi. I'm a third year engineering student of RGKT Ongole University, specializing in the domain of electronics and communication engineering. First of all, I would like to thank the Emertxe Information Technology for providing me this wonderful internship. I'm going to present my project now. The title of my project is IoT based home automation solutions. Contents of the project: C programming, introduction to IoT and embedded systems, introduction to home automation, project definition, block diagram of project, components, coding, simulation and output, conclusion. Now we will have some brief information about each of them. C programming consists of data type modifiers and qualifiers. Modifiers are signed, unsigned, long, short, etc. Qualifiers are size qualifiers, frame qualifiers. Conditional statements and loops. Conditional statements are if else, if, elif, etc. Loops are while, do while, for. Operators are arithmetic bitwise operators. Arrays and pointers. Arrays are single and multi-dimensional arrays. Pointers are special vehicles that are used to store address rather than values. Functions is a block of code which only runs when it is called. Strings are sequence of classes. Storage classes. Introduction to C++ beyond C. Here we are using C++ for writing the code in Arduino. An introduction to object-oriented programming. Internet of Things. Internet of Things is simply called as IoT. The term IoT refers to the things that are connected to Internet. IoT is simply the network of interconnected things or devices which are embedded with sensors, software, network connectivity, and necessary electronics that enables them to collect and exchange data, making them responsive. Now we will have a look at embedded systems. Embedded system is defined as the firmware into hardware to do one specific or few highly focused jobs with real-time constraint. Embedded system is simply hardware plus software which are intended to do a specific task. On the left side, we have the simple block diagram of embedded systems. Here we have processor, RAM, flash storage, clock source, power block, computer interfaces, sensors, other blocks we can add. Introduction to home automation. What is home automation? Home automation means controlling or monitoring the home attributes such as garden lights, heater, cooler, and etc. by connecting them to internet and operating or monitoring them with mobile without any physical interaction with devices. An automated home is always known as smart home. The project definition. The aim of the project is to access and control the home appliances, that is garden lights, cereal tank, heater and cooler, through internet. This home automation project is simulated on the PixSimLab simulator, Blink IoT mobile application used to control the devices, and Arduino IDE to write the code. Below we can see the interfacing of Blink mobile app with PixSimLab through Blink cloud server. Block diagram. These are the block diagrams of the project. There are three main things in our project. They are garden light control, temperature control system, water tank inlet and outlet valve control. In the garden light control, we use Arduino Uno, LDR sensor and lights. LDR sensor senses the intensity of light and it sends the signals to Arduino and it controls the garden lights according to the inputs given by LDR sensor. Temperature control system. In temperature system, there are three parts. They are temperature sensor, heater and cooler controller. We are controlling the heater and cooler by using the Blink IoT app, and the temperature will be displayed on the CLCD. Here, when the heater is on, when the temperature exceeds 35 degrees centigrade, that is human body temperature, then it is automatically turned off and the notification will pop up on both Blink app and CLCD. Here we have block diagram of serial remote tank. Serial remote tank in PixSimLab communicates with Arduino in serial communication protocol. Here we are monitoring the volume of water in water tank and controlling the inlet and outlet valve. When the water level is less than the 2000 liters, it opens inlet valve. If it reaches 3000 liters, it closes inlet valve automatically. And the current volume of water displayed on CLCD and Blink IoT app. Now we look at the tools used in the project. Arduino IDE. Arduino IDE for compilation of codes and loading the codes into the Arduino Uno board. Arduino IDE, the open source Arduino software, makes it easy to write code and upload it to the board. Language used is C++. This software supports different types of Arduino boards such as Arduino Nano, Arduino Uno R3, Arduino Mega, Arduino Micro, etc. PiximLab. PiximLab is a real-time emulator of development boards with integrated debugger. Here we can connect the all required spare parts and we load the compiled hex file. Blink mobile application. Blink is an IoT platform for iOS or Android smartphones to control Arduino, Raspberry Pi, Node MCU through internet. Using this we can control hardware remotely. And requirements: null emulator. Null emulator used in the project to establish the serial communication between Arduino IDE, PiximLab. Components. Components used are LDR sensor, LED, CLCD with I2C, LM35 temperature sensor, heater and cooler, serial tank, Arduino Uno, Ethernet shield. LDR sensor is used to sense light, LEDs represent the guardian lights, CLCD is to display the results, and we have temperature sensor to sense the temperature, heater and cooler are there, and Ethernet shield is used to connect Arduino Uno with internet. Components: Arduino Uno. The Arduino Uno board is a Atmega 328P based microcontroller. This is the microcontroller Atmega 328P, and it has 14 digital I/O pins, of which 6 can be used as PWM outputs and 6 analog inputs. 16 MHz crystal oscillator, I2C and SPI communication interface. Blink console. We create templates here, and we create a template title home automation, and we creating devices here, and we creating virtual pins. Blink app configuration. After creating the templates, we develop configuration to use Blink IoT app. Here we have two tabs, one for temperature control and another for serial tank control. This is the code we have written for our project, and this is the sample output of our project. And now we will have a demo of simulation of our project. This is the code we have written for our project. This is the main function code, serial tank code, temperature code. First we compile the code, and then after compiling the code, we export compiled binary code, and after that we go to the PiximLab. Here this is PiximLab, and now to the setup. Now we go to the setup made in the PiximLab, the setup with spare parts. Here we have CLCD I2C protocol, temperature system. Temperature system consists of heater, cooler, temperature, etc. And then we have Ethernet shield, LDR sensor, and LED lights. We have the LED lights here. This is serial remote tank. Here we are using COM1 port because we are using COM2 port for PiximLab. These become a pair. and we connect them. We connect both the COM1 port and COM2 port. Here it is already connected here. The serial remote tank and Pixim Lab are connected. And now we loaded the compiled hex file. Let me show the interface of Blink IoT app. Here the app is connecting with the desktop and it is connected. This is the Blink IoT app we are using for our project. Now we open it. This is the Blink IoT app. We already made two tabs here. Tab 1 for temperature and tab 2 for serial tank control. Tab 1 used for heater controller and cooler controller. There is temperature gauge which measures the temperature, and terminal which node faces about the heater and cooler. Tab 2 is used for serial tank controller. Now let's see what is LDR sensor. What does it do? If resistance is low, it means intensity is high. There will be no light blinking. If resistance is high, there will be the light blinking because of less intensity. This is the temperature system. And now let's see how our project works. When we turn on the heater, there will be the increase of temperature. We can see that here by CLCD and also in temperature sensor. We can see the temperature increases, then 35 degrees, the heater will turn off. We can see this in the Blink app, the heater turns off. Now coming to the cooler, switching on the cooler, the temperature automatically decreases. We can see in the CLCD here the temperature decreasing when the cooler is turned on, and also we can see this in the Blink mobile app. Now coming to the serial tank, which we are doing in tab 2. This is the serial tank using Pixim Lab. Now we are turning on the outlet valve. When we turn on the outlet valve, we can see the water volume decreasing, the CLCD and also in the Blink mobile app. As I already mentioned that when the water volume is less than 2000, then the inlet valve automatically turns on, and we can see the volume is stable. And we turn off the outlet valve, and we can observe the water volume is increasing here in the Blink app, and we can also observe it in the CLCD. When the volume touches 3000, the inlet valve turns off automatically, as mentioned before. Here we can observe that in the Blink app notification terminal, water inflow disabled, water level is full, water inflow enabled. Such type of notifications are visible in the terminal. We can observe them. We can see the output here of our project. And now I am going to conclude my project. By this project, we are able to handle some of the home appliances through Blink IoT application to send and receive the notification through Blink IoT Cloud. And thank you, Emertxe Information Technologies, for giving me this opportunity. Thank you very much.